When you hit play on Netflix, you just expect it to work, right? Every single time. But behind that one simple click is, seriously, one of the most complex and resilient systems ever built. Today, we're going to pull back the curtain and see how Netflix actually keeps that stream alive. And believe it or not, it's a story of innovation that was born from a complete, total, catastrophic failure.
Yeah, you heard that right. It's almost impossible to imagine now, but back in August of 2008, the entire service just stopped. It went dark. No streaming, no shipping DVDs, absolutely nothing.
And we're not talking about a little blip. It wasn't a quick fix. The whole thing was down for 3 full days. I mean, for a company whose entire business is built on being there when you want it, this was way more than an inconvenience. This was an existential crisis. So, what on earth actually happened? Well, this wasn't just some random technical glitch. This was a moment that forced Netflix to completely rethink everything about how they were built, from the ground up. It was the catalyst for a total reinvention of the company's engineering. And this is straight from the horse's mouth from Netflix's own blog. A major database corruption. One single database going down brought the entire company to its knees. Now, in tech, this is a classic example of what's called a monolithic architecture. Basically, one giant interconnected system. And the problem is, if one critical part breaks, the whole thing breaks. It was a single point of failure. And boy, did it fail spectacularly. So, after a disaster like that, Netflix knew they couldn't just put a bandage on the problem. No, they had to tear the whole thing down and build something completely new. They set out to build an architecture designed not to prevent failure, but to survive it. And this journey led them to pioneer what we all now know as microservices. Okay, so this is the whole game right here. Think of the monolith on the left like one single, massive, complicated factory. If the main power generator fails, the entire factory floor goes dark. The whole operation shuts down. But the microservices on the right, that's more like a city full of small, independent workshops. If one workshop has a power outage, well, that's a bummer for them, but the rest of the city just keeps on humming. That is the kind of resilience Netflix was shooting for. And this is what that city of workshops looks like today. It's nuts, right? Every single one of those dots is a separate service, all talking to hundreds of others. It looks like pure chaos, but it's actually organized chaos. And that is the secret to their stability. They've gone from one single point of failure to this massive web where no single failure can ever be catastrophic. But let's be clear, getting to that crazy-looking web was not easy. This wasn't a weekend project. It was a 7-year engineering marathon. 7 years to move from their own data centers to this massive distributed system in the cloud. It was a huge, deliberate, and incredibly difficult transformation. So how in the world did they pull it off? Well, along the way, they developed a set of core principles for building and running this new architecture. You can think of it as their playbook for surviving in the wild, chaotic world of the internet. And here are the 4 big ideas that really guide everything they do. We're going to walk through each one, because this is where the real genius is. It covers everything from how they handle data to how they plan for growth and even how they test their own systems by, trying to break them. First up, statelessness. Okay, what does that mean? It means that every request you make, like searching for a movie, is a totally self-contained package of information. The system doesn't need to remember what you did 5 seconds ago on some specific server. And this is huge because it means your request can be sent to any available server in the network, which makes the whole system incredibly flexible and resilient. One server goes down, no problem, your request just goes to the next one. Next, this idea of scaling out, not up. This is all about how you add more power. So instead of building one giant, perfect, super expensive server, which is scaling up, you use thousands of smaller, cheaper, and basically interchangeable servers. If you need more power for a big movie premiere night, you just add more servers to the pile. This scaling out is way more flexible and makes the system so much less fragile. The third rule is all about damage control, because you have to accept that things will fail. It's inevitable. So the key is to isolate that failure. By having redundancy, basically making more than one of everything, you make sure that when a component finally breaks, its blast radius is contained. The problem doesn't spread, and the rest of the system can just work around it. And this brings us to what is by far the most radical idea of them all. Instead of just waiting for things to break,
You break them yourself, on purpose, in your live production system that customers are using right now. The goal is to constantly hunt for weaknesses and force your engineers to build systems that can automatically withstand random failures.
And this is its most famous creation. Meet Chaos Monkey. It's literally a program that Netflix built to just roam through their live systems and randomly shut down servers. It sounds completely insane, but it's actually genius. It creates a culture where failure isn't a surprise. It's a constant, expected event. And that forces you to build systems that are resilient by design, not just by chance.
Okay, so Netflix built hundreds of these awesome, resilient, independent services. That's great. But in doing so, they created a brand new and much more subtle problem. I mean, think about it for a second. If you've got all these independent workshops all over the city, how do they coordinate? What happens if two different services try to update your billing information at the exact same millisecond? Who wins? How do they all agree on what the one single source of truth actually is?
Well, this happens to be a classic and very, very difficult problem in computer science called distributed consensus. Getting a bunch of unreliable computers spread all over the world to agree on a single value is one of the toughest challenges in building systems like this.
Now, look, we're not going to do a deep dive into advanced algorithms here, but solving this problem is so complex that entire computer science papers are dedicated to it. You have things like Paxos and Raft, which are just different strategies for servers to elect a leader and maintain that single source of truth. The key takeaway here isn't the technical detail. It's that even this fundamental decision involves these really complex trade-offs between power, reliability, and even just how easy it is for an engineer to understand and use correctly. So after diving into all this technical complexity, let's pull all the way back to the big picture. Why does any of this actually matter? Beyond, just making sure your next episode of The Crown actually plays. This quote right here, this really gets to the heart of everything. See, the old way of thinking was to try and build a perfect system, a fortress, that would never ever fail. The new philosophy, which companies like Netflix pioneered, is to just accept that failure is absolutely inevitable. So you design a system that can not only withstand failure, but can actually heal itself and keep on running when parts of it are literally on fire.
And that leaves us with a final thought. Because the principles that Netflix used aren't just for streaming video. They apply to our power grids, to financial networks, to basically all the critical digital infrastructure that our modern world relies on. So the question we have to ask is, are we learning this lesson? As we build our world, are we building it to be fragile, hoping for perfection? Or are we building it with the expectation of chaos, designing it to survive and adapt?